Okay, so today we're going to go through section 5.2, which is on finding the volumes of things in your graph, okay, using integrals. So we're going to look at the definition of volume, calculus style. Definition of volume says that volume is equal to the integral from a to b of a of x dx, where a of x stands for the area of some piece of your three-dimensional figure. Okay, so if I look at example 2, I'm asked to find the area generated by the graph y equals the square root of x if I rotate it about the x-axis from x equals 0 to x equals 1. First thing you have to do is you have to figure out what shape you're going to make if you rotate the graph y equals the square root of x about the x-axis. And so I went ahead and graphed the square root of x. If you graph the square root of x, you get a graph that looks like that. So if I rotate that about my x-axis, so if I rotate that around this line, what kind of shape am I going to get? I take this graph and then just like spin it around the x-axis. Like if I spin this thing around the whole x-axis and then I look at it from like this angle, what am I going to see? Okay, so let's make like if I took this point and I spun it right on this line, what kind of shape would I get right there?
Circle.
Like a circle, right? Okay, circle. So this is going to give me, if I take this graph, if I look at any point on it, it's going to look like a circle. Okay, so then that tells me that the integral from 0 to 1, because 0 to 1, of the area of x dx. But I need to find then my area. How do I find the area of a circle? Who remembers the formula for area of a circle? I got pi r squared. So the formula for area of my circle is pi r squared. So I need to find my r. So if I took this graph and spun it in a circle, then what would my radius of my circle be?
It would be from point 1 to negative 1, right?
I'm going from 0 to 1. I'm just looking at the area from 0 to 1. So my radius would be like from here to the top of my circle, yes? So, and this line is the square root of x. So my radius is square root of x. Your radius is just formed by your graph. Okay, so let's simplify my area. So my area then tells me I'm going to take pi times my radius, which is square root of x, squared dx.
The square root, the square, you got the square root.
Yes, perfect. So those cancel. So I'm integrating from 0 to 1 pi x dx. Okay, so if I go to integrate pi x, the pi just stays the same. What does the x turn into? X squared over 2. And I'm going to integrate that from 1 to 0. So plugging that in, I get pi times 1 squared over 2 minus pi times 0 squared over 2. Okay, so 1 squared is 1. 1 times pi is pi over 2. 0 squared is 0. 0 times pi is 0 over 2. So pi over 2 minus 0 over 2 gives me an area of pi over 2. So if I were to try to kind of graph that three-dimensional figure that I would get, that circle, this shaded area would be pi over 2. Not a very good three-dimensional drawing, but you get the point. So let's do the same thing for y equals x cubed. We're going to rotate it about the x-axis from 0 to 8. Okay, so the first thing I'm going to do is I'm going to need to graph y equals x cubed so I can visualize what it looks like if I rotate it. Okay, so this is my graph y equals x cubed. I'm rotating it about the x-axis again. So I'm going to take this graph and spin it around the x-axis. What kind of shape am I going to get? A circle. Yes, anytime you spin a graph around an x-axis, you're going to get a circle. So I would integrate from 0 to 8 a of x dx, where a of x is the area of my circle, and I find the area of a circle using what formula?
Pi r squared.
Pi r squared. And what is my radius? X cubed. So I'm going to integrate from 0 to 8 pi x cubed squared dx. Okay. Well, what's x cubed squared become? X to the 6th. So this becomes pi x to the 6th dx. So if I go to integrate it, pi stays the same. What happens to x to the 6th? X to the 7th over 7. And I'm going to integrate that from 8 to 0. Doing so, then I get pi times 8 to the 7th over 7 minus pi times 0 to the 7th over 7. Okay, wow, what's 8 to the 7th? It's going to give you a very large number. Yes. 2097 152. So 2097152 pi over 7. 0 to the 7th is 0. 0 times pi is 0 over 7. So this simplifies to 2097152 pi over 7. Okay, does that make sense? Yes? Kind of? Okay. Alright. You guys, I'm not going to do very many of them because they are time consuming. You can do 360, 1 through 10.